1.2 on modeling exponential functions from a given graph. Okay, we kind of went back to system of equations. Who can tell me what is a system of equations? Hold on. Who can tell us what is a system of equations?
I would always get dropped down in the way I didn't know. Just when you do when you have two equations.
Okay, yes, a system of equations. Okay, you could write this in your notebook if you want to know what a system of equation is. A system of equations is two or more equations, okay, with common solutions, okay? I think I just made that up. Let me just make sure.
Yeah. I remember the definition. Whoa.
Computers are so slow when you type fast. Okay. A set or collection of equations that you deal with all together at once.
I give up.
Ones that graph it are.
Purple man.
Yeah. It's basically what I said.
Purple man. Woo. Ronnie's not funny. So you're gonna donate blood?
I don't know. I'm kind of scared.
Scared of.
Okay, so give me an example of a system of equations.
2x equals 5. 2x equals 5.
That's an equation, right? What kind of equation is that?
4.
Linear equation.
Less than 3.
Linear equation. And then if I say
4x plus 9y.
9y equals 10.
okay, that is a system because now I have two equations and they're both, it's two or more equations, right? I could have a system of linear equations. I could have a system of quadratic equations. Okay, what about this?
What are you doing?
So this is these are both linear, right?
What can you substitute?
Go ahead.
Eliminate.
What are-
not do random substitute?
Okay. So remember, what are the ways that I could solve a system of linear equations? Elimination,
Graphing.
substitution, and graphing. In a system of linear equations, how many solutions can there be? One?
Two.
Can there be two solutions? Well, the graphing, okay. A solution, okay, is an x and a y value that work with both. Graphically, that means you would graph the two lines, and it's where the two lines what? Intersect. So if I have one line here and another line there, that would be the solution, right? So two lines can intersect in one spot. Can two lines intersect in more than one spot?
No, I believe so. They're the same line.
If they're the same line, then how many spots do they intersect in? Infinite. So you could have infinite solutions, or you could have one solution, or
None.
two lines can have no solutions if they are what? Parallel. Do you guys remember that? Okay. You guys in Algebra 2 learned a system of linear equations with 3 variables, and that is like lines in 3D. Okay, so in 3D space, and I don't know if you guys ever learned how to graph in 3D, did you guys? X, Y, and Z axis.
X, Y, and Z.
But the X, Y, Z, you guys never did the graphing aspect, but the Z stands for the third dimension. So if I have a line going this way in this dimension, and another going this way, and then another going this way, if all 3 of those lines intersect in one point, that's your solution. Okay? It's hard to draw here, but let's say one goes this way, one goes this way, and then if all 3 lines intersect in one point, that's your solution. If they don't all intersect in one point, then you don't have a solution. Okay? But it doesn't have to always be same. One is linear, like Antonio was saying, or Anthony was saying. One could be linear, like 2x plus 3y equals 5, and another one could be quadratic, like x squared minus 3, right? So again, we can still solve it by substitution. That's right. That's called substitution. You can't really use elimination. You can still use graphing. So for example, if you have a line here, and then you have a parabola, how many solutions are there?
Too many.
2 solutions. You see that? So that's how you solve a system of equations. A system, if you have one equation, you don't have any solutions, you just have a line or a graph, you know? But then once you have 2 graphs, then those graphs can start intersecting, and those intersections are called solutions. Does this make sense?
Yes.
That's so funny, Goose. Does this make sense? Okay. Now,
I think this is good.
all right. How do you guys know this? I don't think you guys ever probably learned this, but how can we guarantee that there's a solution? If there's 2 variables, okay, how many equations do I need to get a solution?
Oh.
If I have 2x plus 3y equals 5, can you solve for x and y?
No.
Why not?
You can't solve with one equation.
There's 2 variables. If I try to find x, it'll have a y in it. If I try to solve y, it'll have an x in it. I can't really solve it. So if I want to solve a system with 2 variables, how many equations do I need?
2 or
At least two. At least 2. Okay? Then I could solve for y and substitute, or I could eliminate, or I could graph, right? What if I have 3 variables?
Can we equal? Like plug in random. Equal or greater to? So what's one?
For here, you could guess and check. That's always a method, but you have an infinite number of options, so that's gonna take a long time. Okay? 3 variables. How many?
Multiple choice.
That's why I don't believe in multiple choice. If I have 3 variables, how many equations do I need?
2.
3 equations.
3 equations.
Okay? If I have 4 variables, how many equations do I need?
4 equations.
You get me?
Yeah.
More.
Okay. Alright. That's just some background knowledge. You guys cool with that?
Yeah.
Okay. So let's go back here. So we were writing a system of equations, okay? But it's not linear. What kind of equation is this?
This is
Exponential. Good. It's exponential. Okay. And did I already go through the answer with this? No. Okay. All right. So did you guys already find the answer on your own?
We did over that.
Okay. So let's just quickly go. So it says write a system of 2 equations. So I need to have 2 equations, right? What's my first one gonna be? Y equals. Oh, but I'm gonna plug in, cause look, isn't this x and isn't this y?
Yeah.
So 18 equals a times b to the second power. That's my first equation. How many variables do I have there?
2.
How many equations do I need to solve them then?
2.
2. Well, good thing I have another point. 162 equals a times b to the 4th power. So now I have, this is what you guys do, you guys, because you have 4 things, unknowns, x, y, a, and b. But good thing we have 2 points. So now we, in the end, only have 2 unknowns and 2 equations. And that's what you always do in math. You're just kind of deducing until you kind of narrow it down. It's like you're sleuthing. You're doing an investigation until you figure out, crack the code. Okay? So B says solve for A in terms of B.
The next step.
Okay, so this one, how can I get A by itself?
Divide by b squared.
Okay, so 18 over B squared equals A. And what am I going to do with this?
You plug it into
Substitute it into the other equation.
So the other
Which
A.
method is that called?
Substitution.
Substitution method. So aquí I have 16 equals A times B to the 4th. But what is my A?
18 over b squared.
I said A is 18 over B squared. All right.
You're gonna square root.
Okay, do I know how to simplify this?
Square root.
Wait, first of all, how many equations do I have now?
Yeah,
1, but how many variables do I have?
You only have one.
Only 1, because I eliminated the other variable, so should I be able to solve it?
Yeah.
How do I simplify this?
By
What's
squares.
B to the 4th divided by B squared? B squared, right? Because
B
the
squared,
4
that is
minus
true.
2 is 2,
B
so those
squared.
B's, those extra B's
18 B
cancel. So 162 equals 18 B squared. Okay, excuse my not using the right format for this. Just kind of make a little space over here. Okay, so now I almost have B by itself. Who should I get rid of next?
Alright, so the 18.
No.
Oh yeah,
The 18. Okay, divide by 18 on both sides. 162 divided by 18 is 9. Now what should I get rid of? Unsquare it by square rooting it. So B is, wait, is 3 the only option?
No, it's plus or minus 3.
Whenever you do square root of a variable squared, it's
No
plus or
place.
minus. Because look, If b was -3 squared is 9, and square root of 9 is still 3. Okay?
Now plug in B.
Now, wait.
On A.
But the thing is, what does my b represent? It represents the base of my exponential function.
Now you're supposed to find
Can the base be negative on an exponential function? No, the base always has to be greater than 0.
So it's 3.
So this one, I'm just going to choose only one of the two solutions.
So it's 3.
Choose b equals 3.
So after you do that, you solve for A. No?
Now that I solve for b, can I go back and plug that into a?
So it's 3.
I have 3 choices. I could plug it into any of them. Which one looks the easiest?
18 equals A.
This one, huh?
Yes.
I'm going to take that one. I'm going to take 18 equals a times b squared. But now what do I know b to be?
3.
b is 3, so b
Nine.
squared is
9.
9. If I plug that in.
By 9 is 2.
2 equals A.
So 9 times a equals 18, so a's got to be
2.
2. Okay? Now what did I just do? I found a, I found b. Why did I need them? To write my final equation. I'm trying to figure out what is my... Do you guys remember what the whole point of this was?
No, I forgot.
Okay, remember, I know that there's these 2 points, 2 and 18,
What equation are we going to use?
and 4 and 162 over here. Okay?
We need to find the
And I'm trying to find the equation for the exponential graph. Woo! Okay? I know exponentials look like this, but I want to know what that equation is, right? And I know that equation should always look like y equals a times b to the x power, but I didn't know what my a and b were. But by using my system of equations, I figured it out. What is my a?
2.
And what is my b?
3.
And so that is my graph. Okay? So what is that? That's an exponential equation, but it's vertically stretched by a factor of 2. Does that make sense, guys? You cool with that? So if you ever are given, okay, who can rephrase for me? What kind of, these are steps to what kind of problem? Like these steps you should be able to use whenever I ask you to do what?
Find the exponential function of
these
form.
2 points.
Find an equation
Of
of an exponential function given
Given these 2
when you're given 2 points. If you're given 2 points and you're told that it's an exponential, because you know what, if I didn't tell you that it's exponential, can you assume that the graph curves like this?
No.
Couldn't it have been like a line?
Linear equation.
It could have been a line that connects those 2 points, right? Or it could have been a squiggly, squiggly, squiggly or something, you know? But I told, well, that wouldn't be, right? So, but, or it could have been a parabola, right? Or a hyperbola. But I told you it's exponential, so you knew it had to be of this form, and then you just figured out what the a and b must be. You locked it in. Does that make sense, Christian?
Yeah.
Okay.
Hey, where's Fernando?
All right. So now, based on that information, let's move on to the next problem, okay? How about Brian, can you read for us number 16?
The reported application of exponential function by calculating the intensity of
Radiation?
radiation from radioactive isotopes by using a mathematical model. Most isotopes in particular particles decay the decay of the particles by the isotope half-life, which is how long it takes half of the isotope to decay.
Okay, did you guys get that? Did you guys learn this in science before? About radioactive decay?
No, I forgot.
What did he just say? First of all, when do we use exponential functions? Sometimes when we're calculating what? Intensity of radiation, okay? From radioactive isotopes. Okay, so radioactive isotopes, they give off radiation. Do they give off a lot? Kind of. Do they always give off the same amount of radiation?
No.
Why not? They decay, they kind of die out. At first they're giving off a lot of radiation. Radiate, 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 radiate. They decay. Okay? So the radiation decays, so we can model the intensity. So can you guys tell me, do you think this is going to be like a graph that increases like this? Or a graph that decreases? It's going to be decay. All right. So until it's stable. While it's radiating, it's unstable, but eventually it's going to radiate until its radiation stops, and then it's stable. Okay? We measure the rate of decay of particles by the half-life. Well, you know what? Some particles or some elements radiate a lot faster, some slower. So we could compare different particles or elements by talking about their half-life. Okay? So how long does it take you to radiate half of your particles? How long does it take? Well, it takes me 5 years. Well, how long does it take you to radiate, to get down to half? Oh, it takes me 2 seconds. Okay, then you radiate a lot faster, right? Or your half-life is much smaller. Okay? So it's how long it takes the isotope to decay. Half the isotope to decay. Does this make sense? I'm not a science teacher, but does this make sense? Okay. Is it clear? Clear? Isn't it? Okay. All right. All right. For example, what is sodium? Isn't it salt?
Yeah.
NaCl, right?
Let me take out my
Sodium chloride is salt. Yeah, sodium chloride. Okay. So half-life of sodium 25 is almost exactly 1 minute. It takes 1 minute for it to decay to half. So if you begin with 36 grams, then after t minutes, how long do we have left? Let's fill it out. Okay, so we started off at time 0 with 36 grams. After 1 minute, how much is left? 18 grams, because the half-life, which means how long it takes to get to half, is 1 minute. So after, in 2 minutes, how much is there left? Half of that.
9.
After 3 minutes, how much is left?
1.5.
Or as a fraction, we could say 9 over 2, right?
No, it's 1.5.
What's half of 9 over 2? 9 over 4, right? Or 2.25. What's half of that? 9 over 8, which is 1 point. What's half of 25? 1.5. What's half of that?
0. I don't know.
Somebody get out their calculator.
It's on my phone. Man, I got you.
5625.
It's gonna be 5625. That's exactly what I got. Is it 562?
All right.
Good job, Barney.
Y'all got this? So if I were to graph this, what would it look like? Exponential decay. What would be the x-axis? What would be the x-axis? The time. What would the y-axis be? S of t, which is the grams of sodium left. Okay? Which one will be the independent variable? Time is independent of everybody else. And who depends on time? Everybody else. Right? All right, let's go. Including you, and your time is ticking. All right. So it says, now that you have data, technically you have a lot more than 2 points. How many points do you have now on your chart?
Now we have like 6
You have like 6, 7 points. So now do you think you can make an equation that gives a number of grams? So it's going to be of this form. Okay? Now your task is to find capital A and lowercase b. Write the particular equation for the situation using the data in the table. Refer back to steps in the first problem if you need help. Okay, so right now,
So can we choose like 2
do the
points?
same thing. Choose any 2 points there. Okay, and I want you guys to come up with the equations. With your partners, you can work with your partners. Go.
Alright, so which is X? A is X.
We're getting our groups.
Alright,
Yeah.
0. 0 and 36. And 1 and 18.
Come on, Goose. Look alive.
Actually, 2 and
Mathematically.
2 and a half.
Bon, come on.
0 and 36.
Come on, Bon.
That's gonna be y. Y equals.
Oh, so we're gonna use the.
So 38 equals times b with the number of grams at 1. So A equals 38. Okay, look.
Are we using X or Y?
B to the power
Are we using X or Y?
That's 1.
Yeah.
What's that mean?
Okay, I'm gonna put some of your work up on the board so you guys could show us what you did.
Oh, so we're using, Miss, are we using X as A?
No.
No.
Y equals
Your
AB
X is
to
T.
the power of X. That's what you put it in.
Y equals AB to the power, okay.
Yeah.
Yeah,
Except
so it's
instead of
gonna
X
be-
now it's T, and
We
instead
do
of
it-
Y
we
it's
do
S.
it in a notebook?
Yeah, do it in your notebook.
Right?
Okay, so A is gonna equal 38.
Correct. But then we have 2 points. What is the other one? 2 points.
Yeah, so we're using
So it's going to be 9 equals A times B to the power of 9.
Right? Okay.
So we plug in 38. For A.
So we're gonna solve for A right here.
So 9
Four. So it's A. So A equals A.
9 goes into 38 how many times?
Huh?
Come on, Goose. If you guys wait for me to show it to you, that's not gonna be of much help to you.
Hey, you started in. What is the square root of 4.22?
And then we plug in A. Yeah, let me plug that in. So it's 9 equals 18 and B equals, and then it's B2 here. So a B cancels out, so it's B. Yeah, because remember here she cancels them out. And divided by 18. Or is it minus 18?
So it's going to be Y equals 30
And divided by 18.
2.0.
What do you get from 9?
Christian, focus.
What over 2B? What over 2B? Yeah, because
Simplify this, or this is what I got. Y equals 38.
then don't we plug in B
2.05 or
into A? So 18 equals yeah, is that 1? Is it 1? So 18 plus 8 times 0.25.
Okay.
So you divide 0.25.
Yeah, that's what I'm saying. That's what I'm saying.
And then A equals 0.25.
You guys getting it?
Almost. Yes, let's do the board. did that and then I screwed with it.
Number. Let me see. So which choose 2 points did you choose? What were your 2 points?
It was
What'd you get for A?
A. For A, I got 38 times 42.
Yeah. No.
175 divided by
So you use 18 equals 1. What did you do with this? Oh, you plugged it into your
not right to make sure.
Figured out what A and B was. So A is 38, plugged it into 18, and B is 25. So Y equals 30 and a half.
Y equals
Oh yeah. So what's 2 times 18? You guys got it?
We did in the
Okay, I got it then.
No. B is 1/2, but A is not 72.
Is it?
Is it 36?
36?
What?
We got A right at least.
Which one's 36?
Why did we put it in?
oh my god.
Yeah?
9 goes into 36 4 times, dude. And 4 squared is 2. And B is 2.
But that's correct.
I'm guessing we put
And then that's correct. A.
this one.
Wow.
That's correct. So then what? But you're doing it fine.
Squared.
Now we plug this in.
I got one.
Why is it B squared again?
And square it.
Why is it B squared?
1/2. That's 1/5.
Why is it a 2?
How you doing it, Brian?
So A.
Step?
Why is it B squared?
Okay. I'm gonna go over it.
Sorry.
You guys all got it? Okay. Who wrote it nice and neat? Ah, it's a good line one. Okay.
Wait, miss, could we use B squared?
It's not B squared, is it?
Oh yeah, it is. 'Cause when you
Okay,
use
so let's take a look
remember?
at lovely Adriana's. Okay? Okay. So what none of you guys did was kind of label the points that you're starting with, but that's often helpful, okay? Let's first decide which 2 points do we want to use, okay? Now, these guys up here use these, and it's fine. There's nothing wrong with that. You'll get the right answer, but it's just a lot more difficult to work with. So which one did most people work with? 118, and what else? You didn't use a 0? Okay, fine. Well, let's use those 2, okay? All right, let's use those. If we use those, can I rewrite it like this? Can I rewrite it like this? 1, 18, and 2, 9? Right? That helps, okay? So remember, this is like my x and y, so it's t and s of t, okay? It's like f of x, but it's s, okay? So we plug them in. 18 equals a times b to the 1, and 9 equals a times b squared. She tried to get a by itself, so a was 18 over b, okay? And so 18 over b, she got that. What did she do with that? She plugged it into the second equation. 9 equals a, but now a is b over 18 over b times b squared. Okay? Brian, are you with me or are you stuck so far? You with me? Okay. We solved for a and then we plugged a into here. Now, if I simplify that, what's b squared over b? B. So 9 equals 18 times b. And then if I want to get b by itself, what do I do? Divide by 18. And what's 9 over 18? Half. So b is 0.5. Now that we know b is 0.5, I can plug it into any of my equations. She chose this one. She plugged it into here. Since I know 18 is, A is 18 over 0.5, hey, how does she know that 18 divided by 0.5 is 36?
Divided by 2.
Okay, you guys like decimals? I hate decimals. I think fractions are so much better because 18 divided by, okay, hate is a strong word, but 18 divided by half, when you divide by a fraction, what do? Copy, change, flip. So it's going to be copy, change, flip, and so it's going to be 36. Okay? So she didn't actually write the final answer. What is the final answer? Oh, sorry, not y. S of t equals 36 times half to the t.
Oh my gosh.
Because 18 divided by half is the same thing as 18 times 2 over 1. Because half was what b was, and she plugged it into here.
Same thing, oh my god.
She just, you know how she had this equation earlier? She just plugged, once she found out b was 0.5, she plugged it into this equation. Hey, and let's double check, okay? If really s of t equals 36 times 1/2 to the t, let's plug it in. If I plug in 0, what's 1/2 to the 0 power? 1. And 36 times 1 is? 36. If I plug in 1, what's 1/2 to the 1 power? 1/2. And 36 times 1/2? 18. If I plug in 2, 1/2 to the second power is 1/4, and 1/4 of 36 is 9. You see how that works? So we could tell that this was the right equation. Okay? In case you're curious, because I know you guys are, let's see what it looks like when graphed. Don't mind me and all my windows. Okay, so Desmos, you guys know what it should look like if my b, a regular exponent looks like, right? We're all cool with the parent graph? Let's unclick all these guys, because that was from a different lesson. Okay. Y equals, what is it? A times b, oops, A times b to the x power. Okay. Now, let's say remember, b has to be positive. What happens if b is greater than 1? Here we go. Oh, let's watch it move. It's too slow. Okay, remember b has to be what now? Has to be positive, right?
Or else it doesn't exist?
Yeah. That's right. So if it's less than 0, ooh, then it's like that. It just gets steeper and steeper and steeper and steeper, or it gets flatter and flatter and flatter and flatter. And if it gets less than 1, then it becomes a decay. Oh, wait. Growth. Growth.
Is it possible to play both at the same time?
Decay. Wait, what happens? Where's the point that it changes from growth to decay? When b equals what? When b, yes, at 1 is where, because what happens at 1? Well, what's 1 to the x power?
1.
So it's going to be the straight line at y equals 1. You see that? But once it gets more than 1, it becomes exponential growth. Once it's less than 1, it becomes decay. What does this do? Vertically stretches. Remember? So it kind of does the same thing. Oh. Okay. Okay, so, all right, okay, so, okay, now, you guys, told me that it's 36 times 0.5 to the x, and so it is decay, in fact. That's decay. Okay? All right. This is a special class, no doubt. All right.
Hey, he's second in grade book.
Okay. That's why it's a special class. Okay, so here you go. All right. So let's do okay, let's do one more example. Okay. Now, mira, it says not every isotope has a convenient half-life of 1 minute. Okay. So some, like sodium 25, is great. In 1 minute, half-life. But this guy, bromine's half-life is 3 minutes. So after 2 minutes, it's not a half-life yet. So we're not going to care about those. We're only going to care about what happens after 3 minutes, 6 minutes, 9 minutes, because every 3 minutes is another half-life. Okay, so technically, we can count how many halves-lives happened. So after 3 minutes, how many half-lives have we had? 1. After 6 minutes, how many half-lives? 2. After 9 minutes? 3. Okay, so let's fill it out together. So after 6 minutes, it's 2 half-lives. So now what is it? 15 grams, and then 7.5, and then what's half of 7? What's half of $7.50? What's half of $7? $3.50. What's half of 50 cents? 25. So $25 plus $3.50. So what do you get?
$25 plus $3.50?
$350 plus $350 plus 25 cents. Come on, you work at Taco Bell. $3.75. What? That was not even a burn.
Shots have been fired.
No, that's like shows that he's good. He's gonna be good at math. 1.875. Okay, so on our calculator. Okay, wait. So this is after how many half-lives happen after 12 minutes? Okay. All right. Use this data. Please find your new equation.
Wait, do we use the number of half-lives or do we use
What were the last numbers? I can't really.
0.0938.
What?
Which numbers are easiest to work with? The 0.0938? Oh, sorry. It's not 0.0. It's 0.
Lives or minutes?
That's a good question. But we're going to use this one and this one. Okay? For now. What? What? Where did the what come from last time?
Where you did the 36, 1/2 to 30.
We got it because once we found that b equals 1/2, right? We plug that 1/2 back into this equation.
We did the same again?
No.
Hey, remind me, I gotta talk to her about that.
It doesn't really matter. You do it any top side of it. What's 1/2 squared?
Which was nice? Oh, okay.
What is that? 1/2 times 1/2?
My brain is like a little fried. I was not.
While you guys are doing this, can you guys get your test correction so I could stamp it and just spot check it for now?
Of course, miss.
Test correction?
Here, miss.
Test correction?
Mi amor. Mi amor. Mi amor.
Eric.
What? Yeah.
Test correction?
Ay, niño. You wait.
Yeah, test correction. Not fine.
What? See, y'all is the word of the day is legs.
Test correction.
The word of the day is legs. Legs? Yeah. That's what
You guys, I'm so proud of those of you who did your homework.
I just need one letter.
What are you gonna do with your life? I already passed my class. Are you trying?
I got it on.
You're okay with that?
Bro, I got that on Vine.
you gonna become a drug dealer?
Okay. Okay, alright. What, do you guys get it?
Yeah, no.
Can we all agree to use the same numbers? Which ones are we using?
5 and 6.
Man, I got this.
0 and, so 0 and 60?
Yeah.
And 3 and 30?
Yeah.
Okay.
18 and 0.9.
I ain't using my calculator. Can I get the small calculator?
I brought markers.
I want my calculator.
You have your own dry erase? Was that on your syllabus?
Yeah, it was.
Come on. So, 0.5, no test correction, 0.5 divided by 1 divided by 2.
We need to mark a.
Oh, man. Yeah, I thought it was part of the,
It is. Share with your brother.
wire and material. Dude, what's the cube of 1?
Oh, you guys just did it. Oh, you did your left here. All right.
Can we just leave it at?
I'm not sure how to do that.
You could leave it. You could use 1 over 2. Okay, let's do this. So I have 0, 60 and I have 3, 30. That was a 3. Okay, so I have 60 equals a times b to the 0. And I have my part of my system of equations is 30 equals a times b to the cubed. Oh, conveniently, the b goes away by itself. Because 60 equals a times 1, because b to the 0 is 1. So 60 is? Hey, that was easy. Hey. Guess what? What does that tell you? Wait, when the x equals 0, what do you call it on a graph when the x equals 0? The y-intercept, which is the starting point, remember? So when time equals 0, what the y is, that's where we start off. So in an exponential, can we always say that the a is like the starting point?
Yes.
So the a is how much material you start off with. B is like the half-life, and the t is how much time has passed. Okay, that you'll learn that in physics, chemistry and calculus and stuff. Okay, all right. So yeah, you did right. 60 equals a. All right, let's plug it in. 30 equals what's 60 now? 30 divided by 60 is 1/2. And how do I get b by itself?
Cube root.
Cubed root of b cubed is b and b. Okay, and so what's the cubed root of 1/2? When it comes to science, actually having decimals is good. So 0.5 to the 1/3. So b is 0.7937. Okay, so my equation is that b of t equals 60 times 0.7937 to the t.
So what cartoons did you watch when you were a little kid?
Okay,
What?
DuckTales, Chippendales.
We're not gonna
Chippendale.
Cat and dog anymore?
Cat and dog.
Cat and dog?
No, that was only that one example because we only used that because we chose this point. But we could have very well chosen this one, or this one, right? That was only one instance. And yes. Okay?
True.
All right, you guys. Real quick, I want you guys to do these on your whiteboard, okay? Can you please factor for me something as simple as...
Oh, no, that's too hard.
Let's start with the easy ones. Oh, let's start with one from your... Can you factor x squared plus...
I don't see it anywhere.
Plus what? X squared plus what?
4x plus 4.
Or of course I can factor that.
Where is it?
Do you factor? I'm done.
Wait, where is it?
X plus 2, X plus 2.
What are you guys talking about? You're so weird.
Don't you have to move that thing down? Wow, it's upside down.
It's frozen.